Good morning, students. After discussing structures of various atomic orbitals, next step is to understand how they are arranged in order of energy. Means with increasing distance from the nucleus, how the energy of these orbitals change. So let us discuss this. First, we'll discuss energy pattern of orbitals in hydrogen atom. As you all know that hydrogen atom is unique in the sense that it has just one electron revolving around a proton. And in case of hydrogen, there exists only the attraction force between the nucleus and its only electron. No repulsive forces are present here, and due to this reason, the energy of electrons in various orbitals depend only on principal quantum number, means to which shell the particular orbitals belong. And the order of increasing energies of various orbitals for hydrogen is 1s is the lowest energy, then for 2s and 2p. These two subshells related to the second shell, so they have same energy in case of hydrogen atom. And again, energy will increase when electron enters in third shell. So in third shell, all three subshells, 3s, 3p, 3d, they have similar energy. Similarly, in fourth shell, the energy increases, but the subshells of fourth shell, they all have similar energy. So this unique pattern of energy levels is only for hydrogen atom. And here you can see that all subshells that belong to a particular shell have similar energy. And these kind of orbitals, when they have similar energy, they are called degenerate orbitals. And electrons of that electron of hydrogen is present mainly in the first shell, and that is the most stable state of the atom because it has the lowest energy, and that state for hydrogen is called the ground state. And when electron jumps in some higher level, then it will be having higher energy and it will be less stable, and that stage is called excited state for any atom. Let us see this pattern of energy of orbitals in hydrogen atom. For each and every shell, you can say all subshells have similar energy. Next, we will discuss energy of orbitals in multi-electron system, or that means the atoms which have more than one electron in their atom. And you can see here, in case of multi-electron system, the energy of electron doesn't remain same in various subshell. As you can see here in the diagram, if we consider second shell, 2s and 2p, both have different energy. In case of third shell, again, in case of fourth, so in every shell you can say the subshells have different energy, means they are not degenerate in multi-electron system. The reason is that in a multi-electron system, the energy of electrons doesn't depend only on the principal quantum number. Rather, it depends on azimuthal quantum number, that is L. How it depends and what is the cause? Let us discuss that. Actually, all multi-electron atoms which have more than one electron, they have two types of interactive forces in their atoms. Just in case hydrogen atom, we had seen that only attraction between the nucleus and electron is present because of just one electron. But when the number of electrons increases in shell, then mutual electronic repulsions are also increased. Means when there are more than one electron in a particular shell, they will obviously repel each other due to similar charges. And this new type of electronic repulsions result in splitting of energies of various subshells present in the same shell. And energy of electron in any orbital depends on mainly three factors. Firstly, nuclear charge, means how many protons are present in its nucleus, according to which the nuclear force varies. And the second is principal energy level, means at what distance from the nucleus that particular shell is present. If it is closer to the nucleus, then it will have more attraction and will have lesser energy. And if the principal energy level is far than the nucleus, then it will be having higher energy. And thirdly, electrons present in the inner field orbitals. Already जो orbitals filled हैं electron से, they also exert a kind of repulsion to the outermost electrons. As you can see here, when electrons are present in various shells, then outermost electrons which are present in outer shell, they are repelled by the inner electrons. As you can see here, in the inner shell, the electrons are repelling the electrons present in the outer shell. So these outer shell electrons will have a force of nucleus quite decreased, because these electrons doesn't allow to reach that much force to the outer electrons because of interelectronic repulsions. So this effect is called shielding effect, in which the electrons present in inner orbitals tend to reduce the effect of nuclear charge on the outermost electrons. Means अंदर वाले इलेक्ट्रॉन्स बाहर वाले इलेक्ट्रॉन्स तक न्यूक्लियस का पूरा फोर्स नहीं पहुंचने देते. तो एक्चुअली s orbitals are quite closer to the nucleus. Means you can say they are quite penetrated towards the nucleus, so they are less shielded. Means कोई भी इलेक्ट्रॉन अगर s ऑर्बिटल में प्रेजेंट है तो वो उस पे न्यूक्लियस का अट्रैक्शन फोर्स ज्यादा होता है एज कंपेयर टू अदर ऑर्बिटल्स, बिकॉज ऑफ द सिमेट्रिकल अरेंजमेंट ऑफ इलेक्ट्रॉन क्लाउड्स इन s orbitals, and due to which s orbitals have lower energy as compared to the other orbitals or in a particular shell. So shielding effect which is caused by these inner electrons towards the outermost electron is also maximum for s. Means वो खुद कम shielded है but बाहर वाले electrons पर वो ज्यादा shielding करते हैं. Means s electrons prevent most of the nuclear charge to be experienced by the other electrons which are present in outer shells. So this results in a kind of decrease in positive charge experienced by the outer electrons, and this net positive charge is called by effective nuclear charge, and this effective nuclear charge is represented by Z effective, and it can be calculated by subtracting screening factor or shielding factor sigma from the nuclear charge. A nuclear charge, as you all know, that it is equal to the number of protons, that is atomic number. तो एक एटम के ऊपर एटम के आउटर मोस्ट इलेक्ट्रॉन्स पे उसका इफेक्टिव न्यूक्लियर चार्ज कितना पहुंच रहा है, दैट कैन बी कैलकुलेटेड बाय दिस फॉर्मूला. एंड electrons in s orbital will experience greater nuclear charge as we have discussed, because वो बहुत closer होते हैं, ज़्यादा penetrated होते हैं, and symmetrically arrangement electron clouds होता है उनका to around the nucleus, and hence they have lowest energy. So the subshells of a particular shell have, or you can say they differ in energy due to these interelectronic repulsions, shielding effect, and effective nuclear charge, and this is how they can be arranged in increasing order of energy that is directly related with their azimuthal quantum number. Means with increase in the value of L, the energy of subshells also increase. Hence you can say s orbitals will have lowest energy, followed by p, then d, and f will have highest energy. So by this we can understand that how these orbitals we can arrange them in increasing order of energy for a particular atom for various shells. So this is given by a rule which is called n plus L rule. N is principal quantum number, L is azimuthal quantum number. If we add both of these values for a particular orbital, we can arrange them in increasing order of energy. The lower the value of n plus L, the lower will be its energy. Means किसी भी ऑर्बिटल के लिए n plus L की वैल्यू जितनी लो होगी उतना ही वो एनर्जी में लोअर होगा. And if two orbitals have same value of n plus L, then the orbital with lower n, remember this, अगर 2 या 3 orbitals के लिए n plus L value same आती है, तो lower n जिस orbital के लिए principal quantum number, मतलब वो कितनी nucleus के closer है main shell, that depends on the energy. And the lower n value will have lower energy in case two electrons belong to the orbitals with same value of n plus L. So let us calculate n plus L values for these particular subshells. As you can see, 1s is having lowest n plus L value 1, so it will be having lowest energy, followed by 2s, then 2p, and then 3s. As you can see, 2p and 3s both have n plus L value same, 3. So here we will apply that second rule, that orbital with lower n will have same value. So for lower n it is 2p, because for 2p n value is 2, whereas for 3s value of n is 3. So 2p will have lower energy as compared to 3s. So the order will 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 6d, 6p, 4f, 5d, 6p, 5f, 6d. So here in this direction in which these arrows are going from right to left, you can understand the energy levels or increasing order of energies in various orbitals. So here we have the arrangement of various subshells in increasing order of energy which belong to a particular shell, and this is the case of every atom except hydrogen atom, means all other atoms which have more than one electrons other than hydrogen. They will be having this kind of splitting of energy levels in a particular shell. So I hope the things are clear. Thank you. Have a nice day.